All right, good morning everybody. This is my first attempt at making a video for you to help with some of this distance learning. So if you watch the Khan Academy video, it shows you how to change a repeating decimal to a fraction. So I'm going to do that, an example on here, and then we're going to talk about some other ways that you could do it. So in the video, I think they used a different one, but 0.7 repeating. And so what you would do is you would say that this is equal to x. And remember that 0.7 repeating is just 0.777777777. And then, so your goal is to get whole numbers. And so you want to create something that has the same digits repeating after the decimal. So you're going to multiply this by 10. And so whenever you multiply something by 10, you can just move the decimal over one place to the right. So we're going to say that 10x is equal to 7.7 repeating. But if you don't want the 0.7, you could say, it's really 7777777, and so on. And in the video, they subtracted x from both sides. And the reason that works is because in math, you're allowed to do the same thing on both sides of the equation. So if I subtract x on this side, I just take away the 0.7 repeating on this side because they're the same. They're equal to each other. So when I do that, I now end up with 10x minus 1x, which is 9x, and then 7.77777. Oh, you're meeting my cat. This is Jack. And then take away 0.777. All those end up canceling out, and you just have 7. And so when you do inverse operations, that's 9 times x, so we have to do the opposite and divide by 9. 9 divided by 9 is 1x, so x is 7 over 9. And that's the one they showed you in the video. And so now the problem is we don't always end up with just one digit repeating. A lot of times we have more than one digit repeating. So at the end, you want it to be the same thing after the decimal. So let's look at this one, 0.36 repeating. And if you have your note sheet from last week, these are the ones from that note sheet, so you can kind of follow along with that. So I'm going to say that that is equal to x. And so that's really 0.36, 36, 36, 36, and so on. If I only multiply it by 10, 10x is 3.63663, and so on. And the problem with that, if you look at this, you want the part after the decimal to be the same. So this is the point, starts with the 0.36. 10x is 0.63. So in order to have the same thing, I need to get that decimal one more place over. So I'm not going to multiply by 10. I would need to multiply 10 by 10, and 10 times 10 is 100. So we're going to pretend that 100x equals 36.363636, and so on. So now if you look, x and 100x have the exact same thing after the decimal. So I'm going to subtract x from both sides. So 100 minus x, and then instead of putting the variable over here, I'm going to put what it's equal to numerically, because I want that part after the decimal to cancel out. So 100x minus 1x is 99x. And then 36.363636, so on, minus that 0.36 repeating. That part after the decimal is going to go away, and it's just equal to 36. So using inverse operations, I'm going to divide both sides by 99. So x equals 36. That doesn't look like a 6. 36 over 99. And you always, always, always want to simplify your fraction, because EOGs, EOCs, all that stuff, when it asks you to grid an answer, it's going to ask for simplest form. So if you put this in there, it's not going to be the correct answer, because you can still simplify. So both of these numbers are divisible by 3. So that's where I'm going to start. I'm going to use a different color so you can see what I'm doing. So 36 divided by 3 and 99 divided by 3. So 36 divided by 3 is 12. And 99 divided by 3 is 33. And so when I look at that, that can still be simplified. 3 will still go into both of those numbers evenly. So 12 divided by 3 is 4, and 33 divided by 3 is 11. And that is as simple as it will get. So 0.36 repeating will turn into 4/11 as a fraction. I'm going to do one more example, and this one is a little bit weird because we're not used to the digits and how they repeat. So, my very fancy tissue eraser here. If you look at example 3 on your note sheet, if you have it, it's 0.16, and if you notice, it's kind of weird because the bar is only over the 6. And so we're going to pretend that this is x. And I'm going to do just like I did on the last one where I multiplied by 10 and see what that gets me. So if I multiply that by 10, I'm just going to move the decimal over one place. So 10x would be 1.6 repeating. But if you notice, now we still have the same problem we had before. The part after the decimal is not the same. This has a 1 behind the decimal, and 10x does not. So I'm going to multiply by 10 again, or multiply the original by 100. And so 100x, I'm running out of space on this tiny board. If I move the decimal over, would be 16.6 repeating. And so now I have to figure out which ones have the exact same numbers after the decimal. So if I look, I'm really going to need these two because the 0.6 repeating and the 0.6 repeating, the x just has the 1 and we don't need that right now. So I'm going to start with the larger of the two. So 100x equals 16.6 repeating. And I'm going to take away this time 10x from both sides. And that's okay because I'm doing the same thing. It's just like when you add 5 to both sides. I'm adding the same thing because 10x and 1.6 repeating are the same. So instead of writing 10x over here, I'm writing 1.6 repeating. So now, all right, 100x minus 10x is 90x. And 16.6 repeating minus 1.6 repeating, those go away, so 16 minus 1 is 15. Using inverse operations, I get that x is equal to 15 over 90. And so both of those are divisible by 5, so that's where I'm going to start. If I divide by 5, 15 divided by 5 is 3. And 90 divided by 5 is 18. Those are still both divisible by 3, so I'm going to divide by 3 again. 3 divided by 3 is 1, and 18 divided by 3 is 6. So x equals 1/6, or we could say, since x is 0.16 repeating, 0.16 repeating is equal to 1/6. And this is just a coincidence. You can't say, for example, 0.27 repeating. You can't just change that to 2/7. That was just lucky. It doesn't work like that all the time, so don't do that. If you have any questions, post them on the discussion board. I hope this was helpful. Feel free to pause and watch it again. If this works, you'll be seeing more of these. Have a good day.